Hello, 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 dear developers. Let's talk about how do we send our web application to offline in a good sense. Before we go further, let's give some definitions. What do we mean by the application at all for the next 50 minutes? If you attended yesterday's session by Robert Uncle Bob Martin, web in his structure was something on top, like delivery mechanisms, so something pluggable. So I offer you to turn this upside down and let's think about the application, about the piece of software we run on our desktops, mobile devices, so we interact with, and then all this the rest of this beautiful software architecture is more or less server-side, which serves us data and serves the application asset themselves. So we are about this form of application today. What is offline? How do we define exactly what should we have there? Nothing to invite, nothing to invent here at all, because we all know, and for example, our mobile devices and native apps will help us to find this definition. And the same with native apps for laptop and desktop platforms. Just imagine, we start any application, I don't know, something exists, something up in macOS, something from home screen of mobile device, and we don't care about connection status, right? So we know how that works, and we expect to see at least application UI, we expect to see some data, we expect to perform some actions, so we know how that works. Let's just make sure that it's the same for the web. And to keep everything on practical level, I want to give you some foundations of how that works under the hood, plus some very practical like example of usage of one of the libraries. So I think we are good to go. I came to you from Norway, Oslo, where I organize lots of activities for the developers. I'm a big fan of developer communities. What could be useful for you from this slide is my Twitter handle. Why? Because I mainly tweet about the latest news on the web platform, latest news related to progressive web apps, some latest news from the frameworks. Plus, in this presentation, I will have some code samples, I will have some links, lots of links, but I will not focus like in details on these pieces of code, so they are mostly to illustrate the idea. If you want to go deeper, again, follow my Twitter. I will post the link to this slide deck. I stream it from the network right now, like 10 minutes after my session, and this will be extended version of this slide deck. Okay. During the preparation to this presentation, I did lots of like research. I read lots of articles, opinions about web as platform. And what I discovered, the World Wide Web is a new platform, browser is a new operating system, and JavaScript is de facto language. And these are not my statements. I took them from one of the white papers by this folks from Sun Microsystems by those years. What I was really excited about in this white paper is the date of release of this white paper. So it's pretty much what we have today, right? It's pretty close to the reality. Can we imagine the year when these folks came with these statements? 11 years ago, people. So it's just half a year after first iPhone was released. It's the year when JavaScript, the good parts book was released. And it's 1 year before the very first initial AngularJS framework was ever published, like to the developers. So the ideas were in the air for a long time. But let's check the current status, what's going on here. Before we dive deep into the technical parts, I really want to make sure that we are on the same page about perceiving web as application platform. So what do we have in web? Browsers. Browsers are everywhere. browsers or some form of web views. We are talking about something that able to render, say, our HTML, able to run JavaScript in a more or less performant way. Okay, so we don't have to ask our clients, users, customers to install particular version of operating system, install some, I don't know, application server there. It's there on their devices, on billions of the devices. Furthermore, we don't have to ask about a particular version of this, like browser or web view or whatever, because most of them are evergreen nowadays, right? They update it in the background, so we don't care so much. It has its own pros and cons, of course, but it simplifies our lives. Plus, we have really awesome APIs to access directly from our JavaScript code without any, I don't know, plugins, wrappers, translations, whatever. This is really cool. Next, JavaScript. I had hard time to find one word to describe this language, and I ended up with versatile. What do I mean? Like many senses. For example, you are good to go with like object-oriented style, or you can choose functional programming, or you can add some pieces of reactive ideas, right? So you're free to choose how to code your applications. Are you happy with JavaScript as a language, as a developer? It's totally fine to say no, because the current state of tooling is so powerful that you can write literally in totally different language. I don't know, Dart, Clojure.js, or some superset of JavaScript like TypeScript, and this will be transpiled to what browser can run automatically for you. Plus, on the same point about tooling, I think JavaScript has the best class support in all the IDEs like IntelliSense, linting, highlighting, everything. So it's a pure pleasure to be JavaScript developer nowadays. Plus, what I especially love, it's the way how we add new features to this language. So you know that we have this TC39 committee, and it's very conservative in adding new, I don't know, specs, methods, features to JavaScript. And for the reason, because we don't want to break whole ecosystem by some, I don't know, uncareful decision. And it works like they do not invent something from their heads. They look what community need, what community like implemented in form of some polyfills. And it might happen that in the next next version, this feature will land in JavaScript. But again, it's very conservative, which is good in that sense. JavaScript Engine, a huge bullet point for us, for developers. All creators of these engines are focused on performance. So we don't have like huge control on that process, but we just want to confirm that folks from Google, from Mozilla, from Microsoft, they all focused on making the best in class performance. Plus, if you wish, there are some nice embedding possibilities of, I don't know, this full JavaScript engine or some subset of this to your server side, to your constrained device, whatever. This is pretty universal. What's on UI side? You can say, okay, I'm the programmer. I don't care about the color of the button. And this is true, but I encourage you all to care about user experience in general. So maybe like we don't have to architect the blur or shadow or something like really graphic, but with the current status of tooling we have, all this flex layout, CSS grid, CSS variables, you don't have the privilege to say anymore, I don't know how to do this. I don't know how to make this layout responsive. You just use what specifications and what standards includes. No hacks, no polyfills, everything is there. Another important point, all the features resided in the UI layer, focused on accessibility, really important. And in most cases, you don't have to create something from scratch. Huge number of pretty high quality components or libraries, and it's not only about UI layer, but say about all JavaScript modules in general, so you all know and use NPM. And this point, of course, leads to community. We are a huge community of JavaScript developers, of front-end developers. Want some numbers? Please. Latest Stack Overflow survey. Almost 70% of professional developers know, at least pretend they know JavaScript. And if we think that there are some tens of millions of folks who call themselves developers on our planet, it's pretty decent number. So, okay, I hope I inspired you to think about web platform, not about like something serving static documents for us. So it's on positive side. What could be wrong? Are there some issues? Of course, like everywhere. I think the main one is the browser interoperability, but it's something that we cannot control. I mean, to fix the browsers, right? So let's postpone this discussion. We'll have this a bit later. What can we fix here, now, today, is another historical issue of the web. So initially, World Wide Web was invented to serve some static documents or files, if you wish, from remote servers. I don't think it was initially prototyped to be an application platform. So it's historically very tightly connected to connection status. And I'm not saying only about connection to the internet. Even local host connection, if you run your application locally and your local server is down, browser doesn't know what to do. And yeah, of course, I'm saying not only about Chrome. It's all the browsers. General, I just have this Dino as a very good visualization of offline mode and how dangerous it is. So, of course, throughout the years of web exist, there were some solutions. And HTTP cache, it's with us for years. Can we rely on this as front-end developers, as JavaScript developers? No, not at all. It's something that we don't have full control or like control in general. It's all relied on this headers sent from server side. All depends on how browsers understand this. And I bet many of you, including me, did something like, okay, I will open some tabs with some, I don't know, Wikipedia articles, and we'll read them on the plane. Okay, you're boarded, you're offline, you open this website, and the page were unloaded from the memory. It's okay, like, but you think, but they definitely should be in the HTTP cache. But you see offline Dino. So it's something we don't have control. Application cache or app cache was maybe one of the first tries on a more or less web standards-based level to solve this issue. But as most of first tries, it failed. It failed not only because of particular implementation of this specification, which, to be honest, awful for us, for developers. It's like really hard to use. But maybe even more about because of architecture, and it was a declarative way of caching again. So we sort of specify behavior for this or that resource. It's not enough. For current state of web applications, for web development, for our requirements, this approach is totally wrong architecturally. So we have to have a really imperative way to cache resources. We have to be very implicit in writing the code for caching. Okay, if we are talking about installation, so if we cannot cache, maybe we can install the application. And the silliest option is save this web page, and some browsers have this complete. Will work fine for your one page with a couple of images. But of course, this is just more for fun here. Chrome apps was the first serious try to make something installable. But as you can even imagine from the name, it's related to one platform. So it's not connected to web standards at all. Definitely, it was not the way to go, and it's deprecated. These folks, a variety of frameworks or tools for us to convert our JavaScript experience to something installable on the devices. They exist, they are great, but again, this is not the way we want it to be. We have the browsers, we have the web views, they can run JavaScript natively. Why do we want to use like the, say, hardcore, the bottom level platform possibilities to run our, I don't know, regular customer-facing application? No, it's not the way. So, of course, a new standard or new idea came, and I want you folks to tell me how this idea is calling our days. So, to combine caching and installability, we are thinking about, just remember my intro slide. Yes, it's about progressive web applications. But I don't want to convert this session to another one, getting started with PWA. No, we are not about this today. We want to be more focused on offline stuff. This is why let's just check if the definition of PWA is working for us in that sense. Okay, this is what we have on Mozilla Developer Network as a definition, and I'm very proud that I took part in finding this definition. Modern web APIs, yes, we initially defined that we are about evergreen browsers. Cross-platform and the work everywhere, this is exactly the case we want. We don't want to transpile, compile for this or that platform. And user experience advantages. And of course, offline readiness is one of them. So it's totally fine. If we are talking about PWA, part of this is being offline. And I really want to emphasize this very strong statement. Now, today, this hour, this minute, progressive web apps as an idea works everywhere natively, on every platform, on every evergreen browser, with a small comment, right? But we as front-end developers, we are used to this behavior, right? We don't have privilege to know that this super cutting-edge method of JavaScript will work everywhere. It's not the same story as with backends, right? So when we do something for backend, if we even cannot control the version of application server running, we pretty much sure about the version, right? So we know what we can use. It's totally not the case for the browsers, of course, because who knows who our users, variety of operating systems, variety of browsers and their versions. But we know how to deal with this interoperability issue, right? Back to the main issue. So how do we live with keeping this in mind? How can we ever create something for our front end? Well, progressive enhancement. We use this for years on front end. This is our life. This is our destiny, and it's absolutely applicable to everything what's in PWA idea. Back to the relation between what is offline-ready application and what is progressive web application. Maybe this is the last time I mentioned PWA ever on this session. We can check the definition. How can we say that this is a progressive web app and this is a regular web app, right? There are some checklists, and one of them says something like this. And folks, I hope that the last 2 points, it's not related to PWA in our minds, right? This is the default way we build our app, so nothing ever to discuss that our app should be like this. We don't want slow, unresponsive, and mobile unfriendly applications, right? Application shell, what is that exactly? It means that at least UI of our application, we are not talking about the data yet, should be available offline. So in PWA definition, this is exactly about being offline ready. Don't be confused because in some like frameworks, application shell, this is more or less about architecture, not about offline at all. Okay, so definitely application shell is part of offline readiness, right? But it doesn't make our application really cool, really offline ready. We have to add more features, say more on top of what required in PWA. On the other hand, we don't have to think about installability, right? So offline ready application doesn't always mean that user has to install this. No, it really makes sense to add this feature because it's really not a big deal. It's like question of some lines of code and meta information in JSON file, but it's not a requirement. So in very strict definition, PWA and offline readiness are orthogonal, really. They complement each other, but let's not think about like PWA like equals or more or less than offline ready. Good. So now we are fully ready to go, and we start with the application shell. How do we build this experience exactly? Back to our tasks. How to take our web application written in JavaScript and pretend to say that this is now offline ready. Of course, we start with application UI. And again, back to our experience with native devices. We start Facebook from home screen without ever thinking, are we connected or not to the internet, right? We always know that this will start. How to do this for web? Let's architect in a very big picture. What do we need as developers to think about in this flow? And yeah, the application UI might look like this. I don't know, menus, some buttons and placeholders for the data. This is not about, like, for example, actual news. This is just nice placeholders to load data later, if possible. First, we have to define what is exactly forming this application shell. Literally, like index.html, main CSS, main JS, whatever. Of course, it makes sense to keep it as small as possible, right? So we are thinking about first load experience. And we don't want to have this version cached or installed for forever. So we have to keep in mind about versioning and start thinking about how to provide this. Next, on the first run of our application in this web browser, or then, I don't know, in this web platform or in this web view, we have to take this list and explicitly put it into the cache. Not into HTTP cache, which is browser taken care of, but to special cache called cache storage. Okay, let's keep this in mind. On all next loads, we just extract this from cache before even going to the network. So this is actually what is application shell architecture in the meaning of progressive web apps. At the same time, of course, again, if we go back to versioning problem, we might want to check, maybe we deployed a newer version, maybe time to update it. And again, this is all happening very explicitly, so we literally write the code ourselves, if you wish, for every line of item. We do not say cache, so this index.html should be cached for 1 year, something like this. No, it's not about declarativeness anymore. To know how that works, it's super brief intro to service worker. So I hope that front-end developers in the room are familiar with at least foundations, but as I understand, we are pretty mixed audience on this conference. So very basics. This is JavaScript file, after all, event-driven. And in the architecture of the application, it placed in a, say, in the same context, in the same browser, in the same or operating system, but with totally different life cycle. And as it reacts on events, it's event-driven worker after all, right? Fetch all outgoing requests from our application is one of these events, and we are free to choose what do we do in our service worker. Do we go to the network? It could be, I don't know, our API, it could be CDN, it could be our local host, something that outside of the browser, something that needs online mode to be available. Or we can serve the same assets, as I mentioned, index.html, whatever, from cache. So this is a very big picture. In addition, service worker, independently from the application, can receive some events from inside world, from the browser, so, or to be more correct, from the operating system. So operating system can send some events to, say, wake up service worker, regardless of status of our application. It might be like completely closed. Even from the cloud, it's about push notifications, but they are out of our scope for today. Okay, good. Now we know that there is a service worker and it reacts on events, and we have to provide some code. Yes, exactly like this. So let's imagine, what do we have to do to manage the code? One event called install, where we put everything to cache. Another event called activate, where we have to care about some spring cleaning regarding the older version of the applications. This is very, very schematic. So every command line will take, I don't know, some decent amount of code from you, and knowledge of HTTP, knowledge of cache API, which is driving the caching itself. Okay, let's keep it in mind. In the reality, of course, it's way more complex than just reacting on some events, right? HTTP protocol is not the simplest one. It has lots of edge cases. Plus, maybe we don't want to always cache whole the app and always delete whole the app. We might want to do some optimizations. We have to keep in mind that cache is not limitless. After all, we have to come up with some cache invalidation rules, right? We know that versioning is the key. We don't want to always serve the very initial version of the application. Okay? Now, when it comes to serve the data, we have fetch event. You remember, every outgoing request from the application is calling this inside our service worker. So this is about it. And we might respond differently for different URLs. Of course, our application is, I don't know, more complex than index.html. So most likely for application shell, we go for cache-first strategy. For some APIs, we might want to still trigger the network, try to trigger the network first. Maybe it's available. Again, this is super naive, super silly code, and you have to implement every strategy by hand. Literally, go to network. If it failed, go to cache. And at the same time, if network is available, you might want to check if what's cache and in network are good, the latest version. If not, you fetch this again, put into cache. So it's quite of ping pong. This is, in the real world, take some decent amount of work from you. So you have to provide all possible fallbacks if you want to have usable offline experience, not just formal one, right? You have to implement strategies and not just these two. After all, you will end up with some form of routing, right? Instead of this very naive, if this string included in URL request, then this, of course, this will not work for more or less complex one, right? And you want to fine-tune every single detail of how do you cache exactly. You remember, we have very imperative control on the cache. So I listed all these scenarios and real-life examples not to scare you. I encourage you to write your own service worker manually. I promise you'll get fun. You will be better developer. You will know lots about modern APIs. You will explore HTTP protocol in details, but this will take time. Sometimes you just have to do things done, right? Can we help ourselves? And you remember that we are talking about building offline experience today. So maybe after my session in a couple of hours, you might want to have your web app running offline. And if you start writing service workers from scratch, this is not the case, believe me. Yes, we have some really nice tools, and Workbox is one of these helper libraries to automate everything we just listed. It contains a really decent set of features going completely out of the box. You just use these methods, the modules. At the same time, it gives you the possibility to keep your own service worker. So it does not generate the one for you fully, all this, I don't know, piece of code with events, like some of tools do. But it gives you the possibility to keep full control. It has 3 main working modes, so depending on your tool set for your application, you choose the one for you. As the most flexible one, I will have examples on Node module of Workbox. So to start ever with this idea, you just install one helper library called Workbox build. How do we use this? We write quite non-complex. I don't like to overuse word simple or easy. Let's say it like this. Some lines of the code you have to write to connect to your application, like current status, or build of your application status to the Workbox to provide some data. In particular, we want to say to Workbox service worker, which files do we want to pre-cache, which files are building our application shell. How do we do this? We provide some configuration, next slide about this, and then we inject something to somewhere. Let's keep it like this for now. How is configuration looking like? The main properties are about your particular case, right? Workbox doesn't know, do you have it like index HTML or default HTML? Do you have like your CSS files in the root folder or somewhere else? You have to provide this information in form of patterns. It's very convenient for developers. And you have to provide source service worker. And then the magic will happen. How this source service worker could look like? As simple as 2 lines for the very basic case, or a very basic scenario, literally 2 lines. You import Workbox library itself, and this pre-cache and route method does the trick. But to make this working by this previous script, by this Workbox build script, we have to inject information about our resources there. Of course, we have to provide this information, and this magic method will do the rest. It will pre-cache, it will manage the versions, it will serve the files, and it will give you all the hooks to inform user about the latest version. We don't go to these details today, but you have all the possibilities. And manifest itself is looking as simple as this. A list of your resources, like in a very explicit form, and their hash sums to manage versionings. The last step for you is to add this build to your build flow. Don't forget to put it after you generated your distribution files. So then this Workbox build scenario will just go, iterate through your resources, and build fully available service worker for you. And after this operation, you hit like offline button in your browser, and once your application was loaded once, it's offline ready. It's just like magic. Next, we don't want to stop here, right? So this was obligatory part for even call our application in PWA, right? But we don't want to stop here. We want to also do something with the data. What do I mean? Again, let's go back to scenario of Facebook or Twitter or whatever. If we disconnected from the network, we still open the application, it's here, UI, and in most cases, we see some data, right? Some previously loaded feeds, some previously loaded messages. We don't want to lose them because we have them, and why do we have to say, okay, we are offline, despite we have everything in somewhere, like internally in our browser, we cannot see this. This is not the case. So let's fix this. Again, let's start with our naive manual approach. You remember we still have this fetch, and now instead of like splitting between application shell and all the rest, we can go a bit more detailed about subsets of our APIs to build some strategies. Most likely for something like breaking news, you might want to have network first. Otherwise, there is no reason to call this breaking news, right? For something from archive, I don't know, from 80s, you might easily start checking the cache. So once you loaded your news for 1982 and cached them, most likely they didn't change, right? So if they uncache, why not to serve them immediately and they are available offline? Again, you see that this approach is not scalable at all, right? So we have to provide all these ifs. Again, this is very schematic and naive code and super simplified, so it says nothing about strategies themselves. So you remember that you have to implement everything by hands. Going back to Workbox, how will this look there? Pretty declarative. So it's interesting that Workbox actually returns declarativeness to caching of service worker API with some very important notice a bit later about this. So declarative, right? So we say that, hey, Workbox, if your service worker is serving request for this URL, give this strategy. Network first, literally one line and all strategy implemented for us. If we still need to really fine-tune, if our application logic is too complex to use these strategies out of the box, we can provide our own code in form of plugins. And Workbox equipped out of the box with a nice set of strategies, all are for you, nice set of plugins, and of course possibility to write your own one. That's really cool. Next task, number 3, background synchronization. What do I mean by this? In the simplest scenario, just imagine we open Twitter or Instagram, maybe Instagram is a better sample, and we want to post some beautiful photo, and we spend a couple of hours by applying filters, I don't know, brightness, contrast, everything. And then we hit push, and Instagram says to us, server not found. All our work gone, just because we were not connected. Could we just wait for the connection? Yes, and this is what native application does. Native platforms equipped with all the tools for like native code developers to have this experience, but not web. If you ever have this application shell ready, so you're offline, you still see your UI, you might see your data, and if you build some Twitter-like application based on web, we start tweeting, we hit post, we see the dyno, and all our application, all our data lost. How to fix that? It's called background sync, and it's about deferring some actions for the later usage, for when we are going back to online. Hello? Yes, you see me? You hear me? The core difference from, for example, yes, you see me, that's good. The core difference from what we have in, say, older JavaScript methods to check online, offline, we have this for years in JavaScript. The core difference is application, again, might not be open at all. So we posted tweet, we got some message. It's up to us, up to developers to provide this feedback that your data will be posted to the servers later when you go back to online. Okay, we close this browser, this application, and this will be delivered. And of course, this is not possible without support, not only from JavaScript APIs, but from the platform itself. Luckily, we have this and specification, and it's implemented in Chromium. Also, all Chromium-based browsers have this. How does it look? In our main JavaScript code, we sort of register this synchronization, and we might give might want to give this a name. In our service worker, in our handmade one, we listen to this event called sync. You remember on my service worker diagram, we had this purple line from the browser called sync. This is good example of exactly this. Believe me, it only looks simple, but if you want to, for example, organize a queue of the data. So first, even in this sample, you have to care about storing your data somewhere, right? In most cases, this will be IndexedDB, which is not very developer-friendly to use if you use them out of the box. Plus, it might be not only one message, right? So I might want to tweet like crazy when I'm offline, and I don't want that only first or last message will be delivered. So you have to implement form of queue. You have to register these syncs for every single item. Then you have to iterate through these items. Again, it's totally possible for you to code manually, but again, it will take some time. How Workbox does this? In, again, very declarative way. We register plugin. You remember it's based on plugins. Plugin called background sync. Okay, we give this a name plus some parameter. How long do we want to even try to do this? And then the same idea how we do for runtime caching. We provide URL for, and here is different format. So you might want to use new regex or this form to provide these patterns. So literally, if you hit post tweet and with method post, and if you're offline, please go for this plugin. And this way, Workbox will understand, OK, I have to preserve all the data posted to this endpoint with this method for the later repeating of this failed request. As simple as that. So it works perfectly for the majority of scenarios. Looks really cool. So now it's supported in Chromium. And let's wake up. What is the next browser to be support this automatically without any like ever intention from developer side? Who is switching to Chromium engine quite soon, and you can even download the developer version? Exactly, Edge. So Edge, I really encourage you to try this version, and it's absolutely available for the preview. Edge browser by Microsoft, driven by Chromium engine. This is really cool. Last task, and it's like a bit for the future. Now it's only available in a Canary build of Chromium. Hopefully this will land in stable soon. About downloads. So how is downloading of some resource looking like now? We can provide the link on our webpage to, I don't know, mypodcast.mp3. OK, and the user will hit this link, and they will get this download prompt. They will see the download scenario. Can we access this resource, this MP3 file, from our application after? No. It will land somewhere on operating system, somewhere in, like, I don't know, downloads folder. We don't have control over this. Again, going back to native apps. For example, let's take Google Maps as an example. And to go to Serbia, I downloaded the offline version of this map. And I selected the region when I was online. I said, OK, make this data, this region available for me. OK, it started to download. I can close this application. I can fall to offline, I can go back to online. This will be continued. Again, native developers, native mobile developers, native desktop developers, they have all the tools, like initially from the platforms, but not the web. But we have to fix this, and we can do this. So what do we need from background fetch? First, dealing with all this ping pong with connectivity. We have to think about being online, being on stable connection as some privilege, of course. Next, after we downloaded something, we want to use this from our application. We don't have to, OK, you downloaded this podcast, and we are building web application to listen podcasts, to manage them. You have to upload it again to the application. What was the point? We want to have this accessible for our JavaScript code, of course, and we can use the same cache storage for this. Despite this is way larger resource compared to our index.html, we still have a good possibility to put it there. Not by the regular fetch, because most likely your service worker will be killed while trying to download the long request. Plus, we want to keep the full control even when we close the application. Again, I don't care. I can close Google Maps app. I can open this again. It will be still downloading. And of course, it's all about user experience. When we are reasoning about something large to download, we have to provide all the information. Otherwise, this will be really strange that you download some gigabytes in under the hood. Okay, so as I mentioned, this is quite bleeding edge of service worker APIs. Now, this is why there is nothing in Workbox related to this yet. But you remember, we have the full possibility to write our own code in service worker, which will be extended by Workbox later. And this is looking like this. We, in the main JavaScript code, we register this possible download. So we, I don't know, provide the name, the URLs of these resources. We can provide maximum number of bytes to be downloaded. And we have the full control over what's going on with these downloads. We can track the progress during the downloads. And in our service worker, we have one more event called background fetch success. In addition to background fetch abort, background fetch fail, background fetch click, so a whole family of new events where we can actually, again, track the progress and decide what to do next. So most likely, after downloading, we want to put this into cache. Again, I do not show this code. It's very schematic. And maybe we want to show on this downloaded message something very positive for our user. If you go to, if you want, I recently posted a blog post about this, and this will look something like this. This download, say, snack bar is something that our users used to see, right? So it's pretty much the same when you click on just external link, right? Good, so this is coming to the web, and I think these four, say, pillars provide quite good offline experience for us. Let's summarize. Web today now is a full-fledged platform for us to build applications, to build, deploy, distribute, run. All the foundations of this offline readiness, I say about foundations, right? So I'm not mentioning this like background sync yet everywhere or background fetch yet unstable, but foundations like application shell, data caching is up for you. Awesome tools like this Workbox, it's really, really strongly recommended to at least start using before you go deeper into service worker APIs. Then you might want to switch to your custom ones. And let's keep user experience and user needs in mind. So we don't build offline-ready apps for them just to be offline-ready. We build them to delight our users. If you're not inspired enough by APIs I listed for you, you might want to check this link about even more upcoming APIs to close the gap between what mobile can do, not only mobile, say what native can do and what web can do. And maybe you can tell me the name of this code project going from Google folks. Cool. On that, thank you very much. Yes, maybe I have time for one question. Yes, please.
Hi. I was wondering, how do you resolve security issues in sandboxing in that case?
It's a very good question, and the simplest answer is be very careful with what you cache, because all this cache storage is pretty much open and available for everyone who can ever get access to this browser. And we are protected somehow against, say, man-in-the-middle attack, and service worker is exactly this man in the middle in that form attack. We protect it to some extent by possibility to run all I listed only under HTTPS. This is why HTTPS is very important, and your service worker will just not be installed under regular HTTP. So this is like big picture of what we have. So think and use HTTPS.